Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. This is part one of the midpoint formula. So in this video, the formula is given, and we do a problem, and then we actually show the proof, how we find the formula, and so we prove that that's the correct formula. We're going to go over the midpoint formula. The midpoint of 2 points, x1, y1, and x2, y2, so two separate points. I have arbitrarily 2 points here, which I'll call x1, y1, and x2, y2. It's simply the ordered pair right between them. So to get it, what you could do is just draw a straight line segment between those two ordered pairs, x1, y1, and x2, y2. And it's the point in the middle so that this length here is the same as this length here. So this little marking with like 3 little slashes, it means that length is the same as that length. So what we're going to try to figure out is what is that ordered pair xy? How would you get it in terms of the x1s and y1s and x2s and y2s? So I'm going to give you the formula and explain it, but then I'm going to show you why we're sure that really is the midpoint formula. Okay, so here's the idea. The midpoint, which I'll call xy, okay? The midpoint, here's how you get it. It's a new order pair such that the new x value, right, for x, is really just the average of the two x coordinates. So the average, remember, you add and divide by 2, or you can just add and multiply by 1/2 if you have fractions. And the same thing, to get the new y value, it's the average of the y, so it's y2 plus y1 over 2. So to get the new x coordinate, you would take whatever numbers these are for x1 and x2 and take their average by adding and dividing by 2. And to get the y coordinate of the midpoint, we're going to add the y coordinates and divide by 2. So the midpoint kind of makes sense, right? So let's look at an example first, and then we'll go over the proof of it. Where do we get this formula? How are we sure this is correct? And you do have to know a little bit of geometry in order to understand that. All right, we're going to go over the midpoint formula. I'm going to begin by giving you the formula, and then we'll understand why that's true by proving it. And you'll need to have a little geometry to understand that. So the midpoint, which I'll call M, of a line segment with endpoints x1, y1, and x2, y2. So they're two different ordered pairs. For instance, here's your x1, y1, here's your x2, y2, is this M, which we'll call xy. All right, so let's just call this ordered pair here xy. The midpoint is given by, well, the x coordinate is x1 plus x2 over 2. Now that's just the average of the x coordinates of each of these ordered pairs, right? The average of two things, you add and divide by 2. And the y coordinate is the average of the y values, y1 plus y2 over 2. So in this picture here, imagine you have this line segment between x1, y1 and x2, y2. If that's the midpoint, then we know that that length here is the same length as this piece over here. All right, so you could use like 1 hash mark or 2 hash marks or 3 hash marks to show that's the same length. I just decided to do, or as many hash marks as you'd like, some way to show that that's exactly the same length. And we say those are congruent to each other, those two pieces here. All right, before going ahead and showing why this is definitely the midpoint, right, why this formula works, let's just do a simple example. Find the midpoint of the line segment with endpoints. Two, -3, and 4, 1. All right, so let's just use the formula. So the midpoint will be the average of the x values. So the x values are 2 and 4. So if we add and divide by 2, those will be that average. And 1 and negative 3 are the y values. Take that average. And so for the x-coordinate, we get 2 plus 4, which is 6 over 2. That'll be 3. And for the y-coordinate, we'll have y plus negative 3, which is a negative 2 over 2, which is negative 1. Now let's look at a picture and see if that makes sense. So we have this ordered pair 2, negative 3, which is right here. And we have the ordered pair 4, 1, which is right here. So we have this line segment, right? And it looks like the midpoint is about right here. And it does happen to be 3, negative 1. So that seems like the reasonable answer. Now, you could prove it to yourself if you want to simply use the distance formula and make sure those two are congruent to each other. That's one thing you could do. All right, so now let's see why that formula really always works. So let's look at this diagram. We have, let's say, some ordered pair x1, y1, and some other ordered pair x2, y2, right? And we're trying to find the midpoint. So let's say this is the midpoint right in the middle. And I'm just going to call that xy. So that means the distance from here to here is the same as the distance from here to here. So those are two congruent segments. All right, next you have to know a little bit about geometry, what's called a transversal with parallel lines. So imagine I drew a parallel line, two parallel lines right here. So these are parallel, okay? And this line segment is doing what's called cutting the transversal. It's going through two parallel lines, and when that happens, what we say is that this angle, these are corresponding angles, have to be the same. Now, if you look at the picture, they do look like they're the same, right? So we've got that those two angles are the same. Now, if we take two other parallel lines, all right, so I'm going to take these parallel lines now. Here's a parallel line to this point right here. Okay, so we'll say these two green lines are parallel. By the same token, we say this transversal is cutting through these two parallel lines, so this angle is the same as this angle. Okay. We also made two parallel lines in the horizontal direction, and then we cut two parallel lines in the vertical direction, so we actually made a right triangle right here. Right here. Actually, I don't need to show it here. It's kind of unnecessary. Okay, so what we have is two congruent triangles. If you know about the side angle side, if you have two triangles where one angle, I'm sorry, this is angle side angle, you have an angle, then a congruent side, and another angle that's the same in some other triangle, that means all of the corresponding sides and angles are the same. So I can say, for instance, that this length is congruent to this length as well. And I could say this length over here is congruent to this length. All right, so it looks kind of confusing, but what we basically is we have two congruent triangles. All right, so now the key is, how long is this little piece? Right, and how long is this little piece? Well, this is the difference of the x and the x1. Now, so it looks like x is to the right of x1, so this distance right here is x minus x1. And the same thing here. This distance here is the difference of the x-coordinate, so that's x2 minus x. Okay? So we know those are congruent to each other, so I'm going to set those equal to each other. X minus x1 has to be the same length as x2 minus x. And if we solve that by adding x to both sides and adding x1 to both sides, we'll get 2x oops, I put x2, I meant to say add x1. We will have 2x equals, all right, these cancel, so you have x2 plus x1. I'm just going to write that as x1 plus x2, doesn't matter. And if I divide by 2, I get my value of x, which is x1 plus x2 over x. And that was the x-coordinate of the midpoint up here. All right? Now we do the same thing for y. Okay? So this little piece here is the difference in the y values. So that's up at y2 minus y, right? And this little piece right here is the difference of these y values, right? Y minus y1. So by the same token, I could say those are equal to each other. So I could write y minus y1 equals y2 minus y. And if we do the same reasoning, putting the y's on one side and the y1 on the other side, right? Add y to both sides and add y1 to both sides, I get 2y equals y1 plus y2 and divide by 2. And that tells you the two coordinates for the midpoint. So that tells you the midpoint, xy, is actually x1 plus x2 over 2, y1 plus y2 over 2. And the way I remember this is it's just the average of the x-coordinates and the average of the y-coordinates. All right, we'll do some more problems on the next page. Actually, understanding why this is the formula is the hard part, but if you know the formula and can use it, it's really not a hard formula and it's easy to use. But if you want to understand it, it's this picture right here, which I know is a little bit messy and complicated, but it's cool to really understand where formulas come from. Please visit my website at yourmathgal.com, where you can view all of my videos, which are organized by topic.